Hello, I'm Mr. Muskeluk, your AP Chemistry teacher at ChemAdvantage.
Chemistry problem where we're to complete the reaction, write the molecular and the net ionic equation. Now in this reaction we've got two aqueous solutions. We've got nitric acid and potassium hydroxide. Now this type of reaction is one where we're going to have a switching of places. And we call this a metathesis reaction. That's a tough one to say. Let's go over that so we know how to pronounce it. We've got the second meaning, a reaction in which two compounds exchange ions, typically with the precipitation of an insoluble product. Well, this is a separate case, but let's do the pronunciation. Let's see how to pronounce it correctly.
Metathesis.
Metathesis. So tough to spell and tough to say. And let's go back to our problem. Now, as I said, this one is a little bit different because instead of producing a precipitate, a solid, you can see we produce a liquid. When we switch places, we have the H and the switching with the K to make HOH, and we have the K switching with the hydrogen to make KNO3. So let's look at those two. We'll take the first with the H and the OH and see what that looks like. Well, I didn't write it as H and OH. I wrote it as H2O. You could write it as HOH, but of course it's a little bit nicer saying H2O, and of course you recognize that. That's water. It's a liquid. It's a molecular substance. So instead of having a precipitate where a solid is formed, we produce, it's a molecule. And it doesn't ionize, and it's a liquid. It's a pure substance. Now our other substance that we have is going to be the K and the NO3, and we always write the cation first. So that's going to be KNO3 aqueous. Let's check the balancing on this. And yes, we have two hydrogens, one here with the acid and one here with the hydroxide. So we've got two hydrogens. We've got one nitrate. Everything's a +1 and -1. This is an easy one to balance with one all around. One of the things about this is that we're dealing with an acid and a base. This is an acid-base reaction, in addition to being a metathesis, I hope I pronounced that correctly, reaction. And there's one thing you've got to know about an acid and base reaction. You have to identify the type of acid that we're using to come up with this net ionic equation. I'm going to pull up an important sheet. If you're in AP chemistry, this is critical. Without this, you don't stand a chance on the AP exam for any of the acid-base problems. The 6 strong acids for AP chemistry. There are more strong acids than this, but these are the common ones. And even one is pretty exotic here, this perchloric acid. Don't work with this, and read the book on safety for it and have had a lab safety officer check you out. This is an explosive acid. Don't want to deal with that. The others here are hydroidoic, hydrobromic, hydrochloric. The hydroidoic and bromic are pretty unstable. You won't see them much. Hydrochloric, that's in every chem lab. Nitric, very common acid, has some special safety concerns, and the same is true of sulfuric acid. Now you'll notice that I put the sulfuric acid here slightly separate, and there's a reason for that. These you should all be able to recognize and realize that they're called strong acids because when you put them in solution, they will react with water to make H+. It's actually H3O+, but for simplicity, we're just going to say H+. This is acid. This is the essence of acid. And that anion, the chloride, iodide, bromide, chloride, nitrate, are just going to be floating around, not doing much. They're hardly anything. Now, the HSO4 that's left here is sort of unusual because it's an acid in itself. Sulfuric acid, double acid, but the first one is strong. When we say strong, we mean that they completely 100% ionize. When you have a solution of HI, HBr, HCl, HNO3, H2SO4, and HClO4, you don't have any of these together as molecules in a solution. They will have broken up, and they're really just H+ in this. So it's a misnomer. On the label, they should say H+ plus ClO4 because they react with water to 100% ionize. Now, a caveat here. Because they're strong does not mean that they have to be concentrated. You certainly can have concentrated nitric acid, but you can also have dilute nitric acid. Now, they're both strong. They both 100% ionize, but they are varying in concentrations. So it's possible to have a dilute nitric acid solution. In fact, here's where if you wanted to buy some and have just a 1/10 molar nitric acid solution, by the way, this is going to have a pH of 1 also, but there's not much nitric acid in it. So even though you've got a strong acid, you have a small amount in terms of concentration. Get that for 820. If you want to get higher concentrations, where you've got more of this strong acid in a liter, you'd end up having to pay a bit more, of course. 500 mLs of the 6 molar would have 3 moles in that 500 mLs, while this one would only have 0.05 moles in that 500 mLs. Now, if you wanted to buy the strongest you can get, or almost the strongest is fuming, this is about 15 molar, and you have to pay $23 for that. So don't mix up concentration, because you can have low concentration and high concentration. You have dilute and concentrated, but both of these are strong acids, and strong acids 100% ionize. So back to our problem, because this is where we're going to have a net ionic equation that's going to be a pleasant surprise. This HNO3 breaks up into H plus and NO3. Remember I said you have this stuff 100% ionized into H plus, the essence of acid, and the anion. So I've written that. That's what's happened. The potassium hydroxide, this is a soluble hydroxide. Potassium is soluble. It will 100% ionize. And you have potassium ions and hydroxide ions. That's our reactants. When you have this solution, you don't have HNO3, you don't have KOH, you really have H plus, NO3, K plus, and OH minus, all floating in solution, separate with water molecules all around them. They react, and the H plus and the OH minus come together and stick together. Water doesn't ionize much. It ionizes in a millionth, so the predominant thing is that H2O. It sticks together. The potassium and the nitrate, they're still floating around. They haven't come together. They are spectator ions. The only thing that's happened when you mix this strong acid with this strong base, potassium hydroxide, is H plus and OH minus make water. You're making water, and this salt's floating around. Now, net means you only put in what's changing. Well, the nitrate didn't change. The potassium didn't change. So all that you write for the net ionic equation, surprise, surprise, is H plus sticking to OH minus, making these H2O molecules. These two things conduct electricity. This molecule doesn't. Pure water doesn't conduct electricity. Now, I said this was nice because, of course, it's simple, but this applies to all of our strong acids. If you're going to write a net reaction between any of these strong acids and a soluble hydroxide, a acid and hydroxide, all you have to worry about for a net ionic equation is H plus OH minus making water. Now, I wrote aqueous and aqueous, so you know these have concentrations. And here we've got our water, which is a liquid of pure substance. These concentrations can change. Pure water will have its constant concentration, 55.5 molar. If you have a strong acid and a strong base, this is your answer for the net ionic reaction. I don't care if this was HCl, HI, HBr, HNO3. They're all going to end up making just water with the hydrogen ion and the hydroxide ion coming together. You, though, have to remember these acids. You have to be able to identify them. On an AP exam, they won't tell you that these are the strong acids. You're going to have to know that. But hey, there's only 6 of them. And again, these are pretty exotic, but you've heard of hydrochloric, nitric, and sulfuric. I mean, they're well known. Like as any lab will have these all the time. Dilute and concentrated solutions. And look, they even make bottles labeled specifically for them. So those are easy to memorize. You just have to come up with the perchloric, hydroiodic, hydrobromic. Those are fun to say. And that's pretty much it. Writing a acid-base metathesis reaction is fun if you just have a strong acid and a base.